Welcome children. Today's worksheet number 47, periodic classification of elements. In this worksheet we will discuss about modern periodic table or long form of periodic table. In modern periodic table has 18 vertical columns. These vertical columns are known as groups, while 7 horizontal rows, these are known as periods. So modern periodic table have 18 groups and 7 periods. Let us see what decides the placing of an element in certain groups and period. First of all, we will discuss about vertical columns that are known as groups. If we take the elements of group 1 of the modern periodic table, and write the electronic configuration of first 3 elements of group 1. First element is hydrogen and electronic configuration is 1. Lithium. Lithium atomic mass is 7, not 9. So electronic configuration of lithium is 2, 1, while the sodium atomic number is 11, atomic mass is 23, electronic configuration is 281. What similarity do you find in their electronic configuration? Children, in the outermost orbit of all these 3 elements have 1 electron. We will find that all these elements contain same number of valency electron. What do you mean by valency electron? Valency electron means number of electrons present in the outermost shell or orbit. So all these 3 elements have 1 electron in their outermost orbit. So valency electron is 1. How many valency electrons are present in these 3 elements? Answer is 1. So the elements present in any one group have the same number of valency electron. It means number of valency electron is equal to number of group of the element. Suppose an element have 2 valency electron, so it will be placed in the second group. So number of valency electron tells us the number of group of that particular element. The number of shells increases as we go down group the elements lithium, sodium and potassium. If we see the electronic configuration or electronic structure of these 3 elements, number of shells increases as we move or as we go down in a group. As we move down in a group, lithium containing only 2 shells, while the sodium containing 3 shells and potassium containing 4 shells. So number of shells increases as we move from top to bottom in a group. Now we will discuss about horizontal rows, that is known as periods. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon are present in the second period. Look at the electronic configurations. Lithium atomic number is 3, barium atomic number is 4, boron atomic number is 5, atomic number of carbon is 6, nitrogen atomic number 7, oxygen atomic number 8, fluorine atomic number is 9, while the neon atomic number is 10. If we write the electronic configuration is lithium is 2 1, beryllium 2 2, boron 2 3, carbon 2 4, nitrogen 2 5, oxygen 2 6, fluorine 2 7, and neon 2 8. Do these elements contain same number of valence electron? No. Do they contain the same number of shells? Yes. So all these elements contain same number of shells. Is that 2 shells, and number of valency electron increases by 1. These elements of second period do not have the same number of valence electron, but they contain the same number of shells. It means the number of valence shells shell in electrons increases by 1 unit. As the atomic number increases by 1 unit on moving from left to right in a period. When we move from left to right across a period, number of shells remains the constant, but valence electron increases by 1 unit. Number of shells is equal to number of the period. It means if an element contains 4 shells in their electronic configuration, it will be placed in the 4th period. And if the element contains 3 number of shells in their electronic configuration, then it will be placed in 3rd period. Number of shells is equal to number of period. The atoms of different elements with the same number of occupied shells are placed in the same period. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon belongs to the 3rd period of modern periodic table. All these elements are present in the 3rd period of modern periodic table. Since the electrons in the atoms of these elements are filled in K, L, and M shells, means all these elements have 3 shells. We can explain the number of elements in the period based how electrons are filled into various shells. The maximum number of electrons that can be accommodated in shell depends on the formula 2n square, where n is the number of given shell from the nucleus. So if we place the value of n is 1, then we will get number of electrons or number of elements 2. Hence the first period has 2 elements. Second, if we put the value of n is 2, then the number of electron will be, maximum number of electron will be 8. Hence the second period has 8 elements. Similarly, the third, fourth, fifth, and sixth, seventh periods have 8, 18, 18, and 32, 32 elements respectively. These are the maximum number of elements present in the shells. In first shell 2, in second 8, third 8, fourth and fifth 18, 18, and fifth, sixth and seventh 32, and 32 elements are present in the modern periodic table. Now we will discuss question answer. Your first question is, elements fluorine and chlorine belongs to the group 17. How many electrons do fluorine and chlorine have there in outermost shells? So atomic number of fluorine is 9, while the atomic number of chlorine is 17. So you have to write the electronic configuration first. We will write electronic configuration of fluorine. Atomic number is 9. Electronic configuration is 2 7, while the chlorine atomic number is 17 and electronic configuration is 287. So outermost orbit contain 7 electron. So your answer will be 7 electrons in their outermost shell. Write the electronic configuration of magnesium, aluminum, silicon, to which groups or period they belongs to. Atomic number are given to you. You have to write the electronic configuration of magnesium, aluminum and silicon. First of all, we will write electronic configuration. Electronic configuration of magnesium, aluminum and silicon. Electronic configuration of magnesium will be 282, while the electronic configuration of aluminum will be 283, and silicon 14, atomic number is 14, so electronic configuration will be 284. So all these three elements will be placed in third period because they have three shells, 1 2 3. All these three elements have three shells, that is why they will be placed in third period, but they will be placed in different groups. Outermost orbit or valency electron are 2 in the magnesium, so it will be placed in second group, while aluminum will be placed in third group because it has 3 valency electron, and silicon will be placed in fourth group because it has 4 valency electron. Your next question is, write down the electronic configuration of first 3 elements of group 1. What similarity will you find in the electronic configuration of these elements? So electronic configuration of first 3 element of group 1 is given to you. First one is hydrogen, second one is lithium, and third one is sodium. Electronic configuration is written here, 121 and 281. And what are the similarities between these three? All these three elements having one valency electron in their outermost orbit, or have one valency electron. Next question. Your next question is, how many elements are there in first, second, third and fourth period? So maximum number of elements. How many elements? So elements in first period 2 elements, second 8, in third 8, and in fourth 18. How many elements are there in these first, second, third and fourth period? First period 2 elements, second period 8 elements, third period 8 elements, and fourth period contain 18 elements. Question number 5. How does the electronic configuration of an atom relate to its position in the modern periodic table? Electronic configuration, if the electronic configuration of an element is given to you, its number of shells tells the number of period, and number of valency electron tells us the number of group. If the electronic configuration is given to you, suppose an element is calcium, its atomic number will be, atomic number क्या होता है बच्चों? Atomic number is 20. Electronic configuration 2882. Calcium contain 4 shells, first, second, third and fourth. So it will be placed in the fourth period, while outermost orbit contains 2 electrons. It means it has 2 valency electron, so it will be placed in second group. Valency electron shows the group of the element, while the number of shells present in the electronic configuration shows the number of p rate. Thanks for watching.